Hello. Oh wait, the ads are still going. Sucks to be you. Let me just open up project. Get the music turned down a teeny weeny bit. Cool. Cool. Geometric GPU, hello. Wheel bang, okay. Maybe. I was not open, won't even open too early. True. It's a bit early for me as well. It's 7:20 p.m. 7:20, blaze it. Oh. How to make house snap to RVT road. Since I'm up. You would need to see if it's overlapping with the road spline, which should have collision of some sort. And then something. Krezitik. How's it going? And Yaku. And also Monkhead. Good morning. Alright, let's jump straight in. I do remember what was going wrong last time. So we were doing stuff with the RVT, where we had this, where yes, we can define a shoreline, but we couldn't do it with a curved shoreline. I actually want to just go in and make a curvy boy real quick. So it's fine, spline meshes don't have distance fields, right? Yeah, I believe they wouldn't, because the distance fields are like pre-computed, you know? So I would assume that you can't really just distort. I mean, it would be possible to deform a pre-computed distance field. So I mean, it's technically possible, but they probably just haven't done it because, you know, Unreal Engine. Because Unreal Engine. All right, let's see. UVs. Blah, blah, blah. This is, yeah, cool. Oops, I meant to control to that. Where's the checker deselect? Yeah, and then select loops, edge loops, dissolve. Probably do that again. So we're just going to pretend this is our spline. Change the invisible spline mesh to define map boundary and use a distance field to change the map material. Because it did not work. So I want to maybe doing something for the shoreline that we're working on. So I'm using an RVT for the shoreline. Which can, well, it can be read in the shaders and stuff, as well as, I mean, you can't actually read the RVT directly, but you can read the implication of the RVT, you know, in the, what's it called? This is dumb. This isn't gonna work. Let me just do a thingo. Get it nice and big. And then a new... No, not new material. New modifier. Deform. What's our deform gonna be? It will be... Warp? Simple deform. Simple deform. Bend on the Z. There we go. That should be fine. We'll go 90 degrees, why not? Apply. What's the... You know, let me do... From its origin point, let me just measure roughly how big it is. Where's the ruler? How do I measure? U to U. 12 meters. I mean, yeah, that makes sense, because... Yeah, whatever. Let me just export this. JV on RVTs? Yeah, that would be a good starting point, I guess. Alright, it's waves time. Who be wavin'? Okay, so let's do... Well, first we need to, I guess, go to PrismaticaDev. Go to our water stuff. Official water stuff. Let's chuck in the FBX. Blah, 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 blah. Just, yeah, whatever. Import it. It's fine. Just don't fuck it up. So now, if we get this... So this is 1,200 units big. Yeah, message log these nuts. Let's get our scale up by 10. So that gives it a 12,000 unit... 12,000 unit fall off. Which I guess that's enough for now, so... Whatever. Let's give it an arbitrary curve. Blah, 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 blah. All right, let's get the ocean water RVT draw. And we're going to assign this to our runtime boy. To our water data. Chuck it underneath. Cool, cool. All right, we're seeing something happening, which is good. So what we want this to do is... I think previously we were doing some, radial shit. We just get this and put it into the emissive. Here we go again. Yeah, do be like that. So I think this is correct. Add one div 2. Oh, so let's also go half screen. Alright, is this doing the thing? Yeah. Cool, and then we just have to do a linear gradient lerping up towards straight up because the normals get normalized. Funnily enough. So we will chuck that into there. This can then go to there. Or does that need to lerp towards... that will go to... Oh, so I'm guessing that wants to be V gradient from here to there. I think my UVs were around the wrong way. And we want the 1 minus of that. God, I can't fucking do anything right, can I? Jake, how is it going? Okay, so we've now got our shore here. We have our not shore here. And we can then read that. And we know that this gradient is roughly 1,200 units long. So in our Water shader, wherever that is, or a test water shader, more accurately, we need to factor this in. You can see already it's going in the wrong direction, but it is doing something. That's for certain. So the issue last time was in our wave stuff, we have a direction... Well, we need a direction gradient and a direction. Well, actually, no, we only need the direction gradient. Which... it's kind of hard to define, but in here, direction gradient should be our direction gradient. We don't need the direction normalized because we can just get that from the direction gradient and normalize it. So, I mean, that's literally what we're doing. So, we get direction gradient, normalize, dot it against world position, and then that goes into all of our shit. However, we... instead of doing this dot here, I'm pretty sure because this is giving us a... well, it's different here. Input wavelength divided by 2 pi. Could have made more interesting shade. Would be cool. Yeah, we'll do that in a bit. I mean, this will usually be defined by a spline, so it can match, you know, whatever shoreline, whatever the shoreline needs to be. Been doing research on how party animals did their fur lately. Hell yeah. Very cool. Was it shell fur, or was it the other one? So I'm pretty sure this is supposed to be this thing. Yeah. But this won't work. Yeah, you can see it not working because reasons. It works close to world origin, then it just falls apart over here. Parallax shell, I guess? Yeah, that would be probably most performant, but doing what I'll be doing in this game is for like longer fur is doing fur cards, so hair cards for the fur. So then you've got these fur cards coming off stuff. But then what I'll be doing is putting a bone inside all of the bones. So like here's the real bone. And then there'll be fur bones, the brown ones. And the tip of the fur will be weighted to the fur bone. So that when... And this fur bone will be like, just like, you know, lazily simulated. Either trailing behind the main bone or like having some, you know, thingo. But then you get expensive. No, this is like cheap. It's not a bone per fur card. It's a bone per limb that the ends of the fur card is weighted to. It's essentially like, you know how you've got like jiggle bones on the boobs of characters. It's just jiggle bones, but for fur. But it's like one bone per limb. So getting wavelength divided by this, multiplied by this, and then dotted. Why do that? Does it matter if this happens after the dot? It does matter. Alright, we go back. Looks great. So this is supposed to be a direction. This was a direction that gets normalized. So we're using a direction and then multiplying it. So the direction multiplied by whatever this thing is. I guess that's like a distance. Because then when we dot that against world position, we get a gradient in that direction. But it's an infinite gradient in that direction. I mean, what if I just... Well, I mean, currently we're not inputting the direction gradient, right? We're inputting the... Well, the direction. Oh, no, this is a direction gradient, because it's... Input direction gradient. It's just world position, x, y. And that's direction gradient. So we do actually have the direction gradient. which we then pretty much discard. But then we generate... So we normalize that and then re-thingo it for whatever reason. If this was just going straight into here... yeah, whatever. That's a 3, and this is a 2, so you just come out of there. What are you talking about? Vector 2. Oh no, that is a 3er, right? And why isn't this working? Multiply arithmetic between 2 and 3 are undefined. Show me, show me. Oh, that's like... Yeah. Suck my nuts. Alright, that's just because this is now outputting a... Why is the foam mask turning into a float 2? Foam trail mask. Oh, because that's dotting. This is the distance in that direction. So that should just be length here. But then... so it should be length multiplied by u. Test this out. Then we don't need to dot it against there, because we've technically already defined it, but... Okay... Interesting. So these are just all in reverse. I'm guessing because that dot product is giving us the opposite direction. Wow. Interesting, interesting. Alright, let's go back a step. Direction gradient. A direction gradient is saying towards world origin. Here, and over here, it's, well, it's whatever the fuck we want it to be. We append a 0 because it's 2D. And then we're normalizing it and multiplying that normalized value by big number. We're then dotting the direction against world position. So let me just debug this real quick. No, not tangent output. Function output. Alright, we've got some debug shit. So then let's go... Oh, fuck my life. You know what? Fuck that. Let's just bring this... Well, actually, no. Okay, no. Come back, come back. Cool. Let's just grab... It's not right, because it's just this, isn't it? We still don't need direction normalized. You can get yeeted. Alright, let's go world position. Direction gradient. Sorry, that should be negative. Looks like good water plugin on the Fab. Do you mean there is a plugin on Fab? Let's be available in the store when it's done. This will be in the PrismaticaDev plugin. So if you've already got PrismaticaDev, then you'll just be getting this for free, basically. Work with the plugin? Yes. Yeah, that's why I'm kind of doing it in the first place. Come right to Marketplace? Yeah, both of them. Both of them, indeed. So why is this not returning our thing? Direction gradient, doing the stuff, blah, 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 blah. This should give us our wave at that wavelength, yeah. My eyes, my eyes. So then what is this even? Our direction gradient is just our, you know, world origin, blah, blah, blah. And then we normalize that. We then multiply that normalized value by the wavelength, well, the 2 radius divided by the wavelength. So it's very small. That's to like if we got a sine and sine wave did that. Sine wave these nuts. I don't know. 0 point. Oh, it's like 6 something something. If we said, oh, the wavelength is shorter. Well, that's just going to make it stronger or whatever. So that when we dot that against the world position, you know, any difference in selling plugin on old marketplace than on Fab? I have like 10 packs, and on Fab they sell much more worse. Only discounts something. I haven't actually looked at my sales in a fair while. But yeah, so yeah. I'm not sure. I guess I could have an input here called... like, if the direction gradient was just... the R... well, no, let's just multiply by 2. Sorry, by just that. Then we should get single direction waves. Well, no, that's wrong. Right, because it's against world position. Whereas if I just do this, it will just go in one direction. Makes sense. So it's just saying positive, move in positive X direction. Then we dot that against the world position. That just creates a gradient. From, yeah, negative X, blah, 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 positive X, depending on the wavelength. So if the wavelength is lesser, then this should look thinner. Or wider? No, thinner. Yeah. And this is what we generate. If we just got this result and just chucked it into a sine wave or whatever, then yeah, we get this. So this is just our gradient, but we then... it's a gradient that's multiplied by the wavelength and the dude. So then this is our direction gradient. Why do we have to dot it? I guess because on that side... Many of you implement the plugins now in C++. How is this possible? Isn't most of it done in the shader and Niagara? I know they have limited use of HLSL, but how would you use C++? So the thing that separates my plugin from other systems kind of like that is that we have to send in, you know, the positions of, you know, the characters and stuff. Like where their joints are, so like shoulder to elbow to hands, or hips to knees to ankle to foot. And we just send in those positions and a radius and their velocity. And we manually get them and send them into the Niagara system to be drawn. So we don't have to do like a scene capture, or we don't have to dick around with like... there's like this Niagara collision input what's it called? Rigid body input reader something. We don't have to deal with any of that. We just tell it like, yeah, there's a capsule here, and there's one here, and there's one there. And then we compare that against the height RVT, which is how we get the fall off. Of like, you know, where, if the characters are close to the ground and that kind of thing. Where is my... Let's go 100. Why not? Okay, maybe not 100. What's that'd be 24,000 like this. So from here to here is 24,000. So I guess then if we just... So when we give it our gradient, that's in like real world space. So we would have to multiply this by the length of our thing, which would be, what did I say, 24,000? So that is now our direction gradient. Wow, that's so cursed. Or is that just because, right, our gradient doesn't reach? Okay. Cursed, but whatever. If that wasn't multiplied by a huge number, then it would be relatively okay. No. How's this looking in our dude? Probably just get rid of that for now. Okay, so we definitely have a gradient. And so yeah, in order for that to actually be effective, we have to multiply it by the length of the stuff. And that will essentially... Well, yeah, no, that's fine. Why is it that when I multiply it there? Let's just clamp. Clampity. Whatever. Like, why would that be more than... No, stop that. Evil. Why is that going slightly yellow. Hmm? Yeah, the default is up. So why is it that when I... That should be like black here. I mean, it doesn't really matter because we can get the original length to... We're going to fall off the effect anyway, so... We would get length here. But yeah, whatever. So we now have our direction gradient of length 24,000. So then this should, in theory, just... Well, direction gradient. World position, normalize, blah, 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 dot, do the waves and shit. Let's actually just get WPO. Ocean stuff, I assume? Yeah. That is... Okay, yep. It's a bit fucky because RVT's not ideal in this scenario. But this is working. It's working perfectly, actually. Yeah. Absolutely perfectly. Except for here, but this is also understandable because we haven't done a fall off yet. So we my migraine auras. Vibe. Okay. Now some of this is a little bit fucky. I mean, it might look fine in the actual shader. Sorry if anyone's photosensitive, but you picked the wrong stream. So then we would essentially, if we had, so okay, now we can go to our actual shit. So that can all fuck off. We can get this. We can get RG. We can get the length. We can use that as our lerp between our two wave types. The top one is our direction gradient, so we multiply our input by whatever the width of the spline is, which has to be a fixed. So essentially like a distance field in a weird way. Then we have all the stuff, and this one is the radial ones. I just also want to test real quick. If we go to our water data. No, go back. Water data. RVT. Here we go. The water data. If we decrease our resolution, they don't get better. There's like a trade-off between banding and between, well, I guess inaccuracy. Cringe. Okay, obviously this isn't ideal to have this masking. I wonder if I stored it in the base color, if it would... Because I think doing it in a big render target is just like lame, but maybe it could be. Maybe it could be fine. Yeah, let me just test if the other channels have the same issue. So where's our actual drawer? We just said put that in the base color as well. Could also test how the mask and specular and stuff work with it. I'll just break 3. It's like if we did R in specular, G in roughness or something. How would that go? Here. So if we had make vector 2 specular roughness and did that, any difference? 0 difference. Cool. So they get stored as a really shit low quality as well. And then lastly, well, does the mask work better? I might see if this... but then I can't... Alright, what if the base color? What if it was based color? That's also no different. We get the banding. So... it is just a limitation of RVT's nuts and the way that they're stored. MIP value, no, MIP bias the... Does this work? Seemingly not. Let me just get... well, we had the normal, so let's get it back. Let's chuck that into our base color for a sec. And yeah, we can see the banding here, pretty obviously. But if I put the MIP bias up, does that actually work? Versus 0. It does. Interesting, interesting. I thought they got rid of this because this pin wasn't there anymore, but I realize now it's down here. MIP value mode. So you can use an absolute MIP level from the MIP level pin. And that also works in vertex shader. So, in our RVT, number of low MIPs to remove from the texture. Don't remove any. Do we have a number of MIPs that we can, like, tell it to do? No. But, I mean, this is good, because it means we can specifically tell it, like, hey, you are... What if the MIP is out of bounds? Does it then just use the low... Interesting, interesting, interesting. How many MIPs do we have? I think it must be 10. Right, this is good. This is progress. Fuck, I didn't actually... This makes me want to, like... I need to write a little note on my RVT video. Also, Shinao Yokosuka. Your vids are always helpful, man. Love to buy you a drink for a good job. Well done. Thank you very much. Super appreciate it. Thank you very much for the bits as well. And thank you for watching the videos. Thank you for learning. It's super appreciated. Those bits will buy me an extra coffee. Let me go to edit video. You can specify there's only an RVT by clicking the sample RVT node and scrolling down to click this texture sample arrow. Oh, angled brackets aren't allowed? Cringe. Texture sample MIP value mode. This can be really helpful when you want to sample, when you want to blur the RVT result. For grass culling, etc. Culling/coloring, etc. Cool. There we go. Interesting topic today. Yeah, it's going to be a lot of fun. It's going to be a lot of fun. Maybe. Possibly, maybe, potentially. Yeah, okay, so see how we're getting this, again, the banding. We can get rid of that using mipping, which is good. I just want to make sure, so down here we've got the river flow direction, which we would want to be high res, you know? Or high-ish res. So yeah, blah 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 blah. Border padding, texture compression on. Number of low MIPs. Can reduce peak virtual texture update cost, but will also increase the probability of MIP shimmering. Well, yeah, I don't care. So back over in Ocean Land, we have this shit happening, but we can just say, hey, go to number 7. Or go to number 10? I don't fucking know. Okay, that's the max amount, apparently. If we go to 3, we get banding, pretty obviously. But because this is such a big area, then... yeah... I guess it's also just more obvious over here because of the fall off to black. So once we have... let's plug all our stuff back in. This was specular, this was roughness, this was base color, this was opacity, this was normal, this was world position offset. And so yeah, we use the length of that. That needs to be inversed. Inversed. Does it need to be inverted? Oh, no, I guess that is technically... the length here... oh, these are just around the wrong way. Right. Length 1 minus. Thank you. Yeah, it's doing the effect here, but not over here, but we want it the other way around. And the reason it's getting all fucky here is because, again, it's like going very close to 0, so we get divide by 0 stuff. So now it should be doing water waves towards the shore over here. But over here, it's going in the ocean direction. Sick. And this should work at any point. Anywhere. Yeah. I think that's maybe that isn't correct entirely. Maybe... oh, I mean, that's going to look dumb because it's the fall off, but... let me just change the direction here to world position X. Why are you going sideways? Hello? What the... eh? Direction gradient. Ah. So confused. What have I done in here? Ah, direction gradient. Oh, right. It's because it's... it's because it's doing all 3. Because it's scalar. This would need to be multiplied by... no, multiply. Multiply by 0, 1. Or 1, 0, sorry. Right. I don't think that's supposed to happen. If I just put a singular in here, then it'll be completely dicked up, but... No? But then how do you even... Right, because it's doing it against world position. So does that mean this actually isn't working? Yeah. Let me just get a really big plane. Although our RVT isn't very big, but... Okay, let's just make this smaller for a second. Let's go... Fuck, even like... Yeah, 10... Also, this isn't really giving an actual curve. I just realized the drawer. Because we're getting this number transforming from world to tangent space. That's just like the same as doing like we want to convert tangent to world space. Like that. Or the other way. So, is it possible to also apply wetness to the sand? Yes, it is. It is. Very much so. I'll be doing that in a bit. So you will see how I end up doing that. There we go. Now, is that the true gradient? No, not quite. But is that just because my mesh sucks? Or because I suck? I mean, that looks like it's correct, right? Because, yeah, as that goes up, and then da-da-da-da-da. So, no, that is correct. We would also need to give our oceany thinger, our testo, the correct length. So that the waves are like the proper, you know, proper thing. We would also need to invert the direction. Or I guess probably in the drawer itself, do negative y. Negative y tangent. Yeah. Hmm. I mean, yeah, it is working, I guess. So let's go, yeah, 20,000. Meaning that, yes, it's 24. 24,000 again. Cool. This is very good. This is good news. Hashtag good news. Okay, so we've got our waves doing the thing. Next step is we need to actually get this into Niagara at some point. Although I think I will optimize very slightly. Let's see. I also want to do like more of a thing. More of a thing. Right, so this is giga messy. And I hate it. But it's also necessary. How can we unfuck this? I mean, for one, this noise stuff doesn't I mean, it is helpful to have in there, but also... Right, well, no, technically doing it one by one is... technically cheaper to operate on 2 single floats than it is to work on a vector 2. There's this weird... This is something, I think it was a Ben Cloward video. But there's a, operating on a float is the cheapest, then operating on a vector 4 is the second cheapest, and then vector 2 and then vector 3 for some weird reason. So if you think you're being smart by, like, packing... sorry. I mean, like, operating on 4 separate float values is faster than operating on 1 vector 4 value. So if you think you're being smart by, like, you know, getting these values, doing, like, a make float 4, then multiplying it by something, and then breaking it again, chances are it's not actually as optimal as just doing 4 multiplies separately. Because essentially under the hood, that's exactly what it's doing. Anytime it goes to here, it will essentially break these apart, I'm guessing, multiply them all individually, and then reassemble them. And so you're just adding extra steps. Multiply it 4 times faster than combine them before multiplying? Yeah, apparently. Like... yeah. It's quicker. GPUs are just weird as hell. Which, like, it doesn't make sense to me either. Yeah, it's kind of nuts. Alright, we've got time. Yeah, so I kind of just want to come up with some better... because I don't want to... I feel like distorting time by some, like, really low-frequency sine waves... It's gonna end up looking better, and it's also gonna be way cheaper than doing more and more Gerstner waves, you know? And we're still gonna get those interference patterns. Because if I just, like, let's just, for a second... This is gonna look super dumb. But if I actually show you what my waves look like without any time distortion... then, you know, you'll be like, what the fuck? Like, it looks dumb. Like, look at that. That looks stupid. And if I just get rid of the noise real quick. So this is this is what my Gerstner waves look like. Which looks stupid. And then usually what you would do is add more Gerstner waves going in, you know, random directions. And that would kind of break them up a bit more. But what I've opted for is to just distort the input time. Wherever it is. Here. No, here. That goes into all of the smaller waves and stuff. So that they all crisscross over each other a bit more. Do you know if a control rig SABP can be used as an animgraph node in different animBPs for different skeletons that have to be assigned to a different... assigned to a specific skeleton. I'm pretty sure Control Rig can get bones by name. I'm fairly sure. So yeah. I think you can make generic control rigs that can be used across multiple dudes. Right, vertex interpolator. I forgot. Let me I just wanted to see how this goes out further. That looks so cursed. Yeah, look at that low poly ocean. Beautiful. Okay, so floats, waves, water. True. It's funny. So funny. So what we are doing here is some distortionators. So we have the size of it, the magnitude of it, and then, well, we can do some forward, we can do some backwards without having to fuck with it too much. But I just wanted to add another set of very low frequency ones. So this will be like on the order of like, 10,000 units. 10, 1, 7, 4, 6. And this can be 10, 2, 7, 4, 7. Add them together. Multiply them by some value. And then add that to time. And then if we put that into our, highest frequency one. Sorry, our lowest frequency wave. Then in theory it should, start to break it up a bit more. But we can go like, more extreme. And so then we start to get some, well, okay, that's a little bit too extreme, but you can see that it's starting to break up the effect to some degree. And then we could do the inverse of that. Sorry, not, we want to time minus the offset. Which can be for this one, if we wanted it to be whatever. Yeah, okay, so now we can see that, we're like softly breaking up the waves a bit more. So that, in some areas, the waves are a second ahead in time. I don't know whether I want to hard code these values or not. Because, like, if they're hard coded, then It's more performant. But at the same time, like, I don't know. Because the only problem is that, yeah, this has to be in Blueprint for the buoyancy to work, and also in here, and also I guess in Niagara as well. So maybe it would just be a better idea to parameterize all these in a collection, and then do a thing. Gerstner with the PrismaticaDev plugin. Really appreciate the work you put into it. Notice on the features page it mentions wind simulation for clothing. Is there an example of clothing in the demo level? And then plans to expand on this or perhaps create a tutorial. That's a good question. I haven't really found a good way for it to, at least on the CP, like to, you know, do bone-driven clothing yet. I know someone got it working with with GPU cloth sim. But what I mainly meant by that is if you're doing like shader clothing, you know, like if there's wind on a character and you've just got like a kind of a jiggle shader, you can drive that using the plugin. Yeah, all right, let's do a... Shit, what are we going to call this? The PrismaticaDev buoyancy thing? This is just a... Wait, what is it? A data asset, I guess. Can a data asset... Can you implement boats or just use buoyancy for floating debris and stuff? Yeah, there will be boats. There will and shall be boats. Just trying to think of a nice way to do this. Would it be a component? But I need it to... I could do an actor with a construction script that's just called the manager thing. Oh, fuck, I don't know. I could put it in PrismaticaDev itself, but I'd rather not, because some people might just want the buoyancy without the PrismaticaDev manager existing. I guess a data asset. Ocean waves data. And then functions, and these can be applied. Yeah, call in editor. Okay, so this is going to be called update collection params. which will then actually apply them to the collection param. So we need... Well, we need a collection first. Annoyingly. Material, parameter collection. This is called the Pris Ocean Waves. Surely you be together with the rivers, which I thought part of Prismatic. Yeah, that's true. Although, like, I guess so. But I mean, the rivers... You'd want unified. Yeah. I'm trying to figure out how I want this to go. Because, yeah, we can have oceans and then rivers going into the oceans and that kind of thing. But the river parameters... Fuck, I'm not sure. I just don't want to put it in the PrismaticaDev manager itself. Because PrismaticaDev is about effects and visual stuff. Whereas this is like buoyancy and gameplay things. Whereas PrismaticaDev doesn't actually influence gameplay at all. It has zero gameplay logic. It's just an endpoint for stuff. Subsystem makes sense. Yeah, subsystem or I think just a data asset that... Well, yeah, no, because I guess we need to get the current values and shit. So maybe a subsystem would make sense. Although I guess if we just have an actor manager, and then the buoyancy components can just look for the actor manager on, when they get initialized. So on their begin play, get a reference to it, and then it can just steal values from the actor manager. To then, be like, okay, what's the current, ocean wave amplitude? Yeah. But yeah, we do need this collection parameter. Although I guess we've already got the PrismaticaDev collection parameter, which... Again, some people might just want to use the ocean shader and everything without using that, but having a separate collection parameter... Do they still have the limitation of... like water? Oh, sorry, not water. Materials. The fuck's a texture collection parameter? Oh, texture collection. Right, that's for 2D. What type is that looking for? Texture collection, right. Yeah, so if I had environment weather, desaturation, then I also had the ocean waves. That doesn't have any values. Hold on. Tutorial MPC. Time. Blah, blah, blah. Add them together. Put that into base color or something. And then one more from a third material parameter collection. Does it get shitty at me? Yes. Material may only reference 2 different collections. So fucking dumb. Okay, so what would people be referencing in the ocean thing? Well, they'd have their own, like, weather system. Probably. And then also the PrismaticaDev thing. Do we have to just tell them to, like, yeah, update this parameter collection through your weather system so that you've got, you know, variables in 2 places that are just paralleled? Because do I really want to add more shit to the PrismaticaDev material function? Because, like, there's a lot of fucking data that needs to go into it. I guess I'll just add it to the material parameter collection. Oh, it's so yuck, though. I mean, yeah, a lot of it is going to be referenced side by side, like the water location and the wave intensity and everything is all, you know, when we're doing the wave particles and stuff, we will be using that, so... Alright, let's yeet that one then. So, official water stuff, ocean waves, we get rid of. The ocean waves data... I mean, that could probably be a style thing, right? I can apply PrismaticaDev style dude. Simulation profiles. New style profile. Profile based simulation profile, style profile. How are these set up again? Surface style profile. We have a bunch of things. Oops. And they tell it how to... Right, that sets it on the Niagara system, but these don't actually set... I guess it's probably a bad example there. Do they set foliage deform style profile? I guess that is all just in Niagara and whatnot, but I guess we could... There's nothing stopping us from making it set values on the thingo. On a material parameter collection. Or I guess it would also need to set it in our manager thing. Like our buoyancy query dude. Or buoyancy components or whatever the fuck they end up being. So yeah, let's do one here. New blueprint class. Style profile here. Although this does change at runtime, so like it's... Well, I guess this... All this data doesn't change at runtime. So what else needs this? So we have the collection parameter... Material collection parameter, which then propagates to the Niagara parameter collection, which makes it easier. And then I guess this would also need to tell the buoyancy dude, you know, what the hell's going on. Yeah. All right. So... PrismaticaDev MPC. So let's say waves. Let's just call it ocean, I guess. It's ocean waves. I mean, lakes can technically get waves, but that's up to the player to define that. Sorry, what are they called? Developer. Right. Ocean. Ocean global. Oh, ocean amplitude? Ocean deep amplitude. And then we also have the amplitude multiplier. And another one called ocean shore amplitude multiplier, because they're separate things. We have the ocean shore length, which at the moment is 24,000, but whatever. We then have a bunch of fucking like wavelengths. Which I guess, yeah, are all scalar values, which is ugly as, but... Waves upon sufficiently large body of water. Exactly. Unless I just... I don't want a hard... Well... Ocean wavelength 01. Ocean wavelength. Oh, it actually... Huh. No, fuck you. Go back. Oh, fuck. Ocean wavelength 1. And then this one, duplicate. And then duplicate. And then duplicate. How many wavelengths do we have? One, two, three, 4, 5, 6, 7. And then 4 noise ones, but that's a different thing. I could do something kind of sneaky. No, not worth. No, this is fine. This is hashtag fine. 1, 2, 3, 4, 5, 6, 7. Maybe the smaller wavelengths don't need parameters. User can adjust the graph if they really want to change it. Yeah. Well, it's more so that just when I'm dicking around with the parameters as well, that it applies it, you know, globally, not just in the shader. How much you dick around with the smaller ones, though? Well, yeah, but anyway, it's like, you know. I think I'll up it to 8. And then I think what I'll do is just put them in vector parameters. Just be like value, you know, values 1 to 4 and values 5 to 8. Just because it's such a fucking pain to do all that shit manually. What do you reckon? Or just do it like this. It'll be... They're never not going to be sampled altogether, though. Do it like that. As in, like, as vector 4s. As floats. Okay. Alright. Alright, they are all scalars now. But I think 8 is a good number. Good maximum number. So I will chuck one more in there. Although these noise ones, I don't know if they're... Like, they do affect... I mean, currently they're not even fucking... The noise amplitude is at 0. Right? Also, what's this angry at? 2 landscape actors, wow. Landscape these nuts. So yeah, the noisiness just does some, like, you know, omnidirectional bits. Like this. But it should never really be high enough to actually affect the buoyancy calculations. least I wouldn't think it would be. Because, like, that versus that, you know, there's no real difference. Oh, like, it's minimal. But, yeah, I don't think we need to include that in the buoyancy calculations. And, I mean, honestly, we probably could get rid of even the smaller ones in the buoyant. Like, we could just do the first 4. I mean, you could probably just choose that. In the thingamajig. There's be lots of comments in the shader graph for things that might want to change number of wavelengths, but obviously might be early for that. Yeah. I mean, that's kind of why I want to do a lot of it in here. But yeah, also like switches to just turn off some wavelengths from even being computed in the shader for like performance sake. Can't do number of waves in there? Yeah, exactly. Oh, technically I could. By having it turn off a switch in a, you know, material instance, or material child. Yeah. What's majors to buoyancy in UE? Depends how you want to do it, but in my case, we have a deterministic wave shader, so it's based on game time. And then what we will be doing is asking, on the CPU, knowing that our water plane is like, you know, here. When we're colliding with it, or we're within, you know, a box, we can then ask for our character's position, what, you know, amplitude, or what altitude, sorry, would our waves be at if we were in this position at this game time. So, yeah. Then we can apply a force, a buoyancy force upwards, or not apply a buoyancy force if they're like above the waves. And then we can also apply the water's velocity, and we can also apply the thing. Amethyst, hello. Just taking for buoyancy where I packed the volume with voxels, did the same wave height pro, worked pretty well. Yeah, so doing it like with a voxel technique like that, where you always have the data available, works really well when you've got heaps and heaps and heaps of individual objects, because then they can just look like you just do the buoyancy calculation once in, you know, in a voxel grid. Or even like a, you know, a texel grid. And then they can just look up from the position. But obviously you have to do that, you know, every frame, or you could do it like on a rolling update or whatever. The way that I want to do it is it scales with the amount of things that need buoyancy. Or need... I guess some singular buoyant things would have multiple buoyancy points, at which point maybe you're doing a voxel approach might be better. So you essentially generate, yeah, like a low thingo version of the waves. Obviously that doesn't scale to really far away, but for my project, I wouldn't need to do that, so... Yeah, I don't know. I mean, it's a good thing to think about. Oh, the boat mesh got filled with voxels and they probe. Yeah, okay, I get you. I thought you meant you do a like a set up a volume that always has, you know, it calculates it for a bunch of voxels, and then when you do your boat, you know, voxels, or like, what are they called? Little pontoons? Like socket points? They can just read from the voxel data rather than having to compute it all individually. So if you had like, I don't know, an 100 or like a 50 by 50 buoyancy, like shared buoyancy data thing, and you had 100,000 buoyancy points, they could just read from this lookup table instead of doing 100,000 probes. But again, it's a scalability thing, because if you had a readily available buoyancy, you know, voxel volume, it would have it'd have like a, you know, a higher upfront cost, but it would scale way better, because you'd only have to probe areas once. But then if you do it per object or per buoyancy point, then if you've only got one thing on the ocean, then it's hella cheap. But then as you get more and more of them, so I guess you could like switch out at some point and use like the nanite of buoyancy. Yeah, exactly. Yeah, just pre-compute a bunch of stuff and then share it with everything. So anyway, we've got the ocean wavelength 1, 2, 3, 4, 5, 6, 7, 8. Then we have the... God, how do I even... I don't even know how to quantify these time distortion values, because it's literally just arbitrary, you know? Like, get world position, some random-ass sine waves, add them together, and then, you know, add that to the time of the Gersty boys. Mega Boy will be introduced in UE5.6 and will require ray tracing. Ray traced buoyancy when? Buoyancy. Buoyancy. I'm out of coffee. I might do the distortions in... but then I want to... I'm just trying to think of a nice way to do this. Because at the moment I've got 4 distortion... I guess they're noise fields, right? And so I can either hard code them to each, you know, set of waves or something. Because like I said, these noise fields are like what stops the whole thing from tiling and looking really dumb. Like, without them, our waves look like Gabaggio. So this is without the noise distortion. Or without time distortion, sorry. Looks super dumb. Yeah, you can chuck a link in Twitch at least. I will also be right back because I need to wee. Hello, I'm back. Maybe we could do some 4 vectors called... how much more is this going to complicate the shader, though? Well... Shader big glowing? True. Yeah, it's a bit crazy. That's my eyeball. We could do the R length, or the R period, G period. The R period, G period, the offset, and I guess we only have to do an offset for the other one, though. Or do we? Is the offset even doing anything? I guess no, past a point, it's not actually... Just saying you are ahead of the other one. Which Because they're non-recurring thingos, that shouldn't actually matter. So, R period, G period, an amplitude. But then what I was thinking is, oh, maybe if these are like, you know, 4 vectors or whatever, each wavelength could ask what it's being distorted by. So like if there's 4 channels, we'd, you know, each of them would have an influence, like, oh, this is distorted by number 1, and this one's distorted by, you know, half of number 2, and a single of that one, and whatever. But at the moment, it's just like the first 2 are the big one. The next 2 are this one, the next 2 are this one. And that kind of thing. Just with different amplitudes and offsets. And yeah, like the noise offsets are important, funnily enough. The annoying part is that it's so arbitrary, right? Like it's art. It's art at this point. And I hate it. But there's no science going on. There is nothing. It is simply just some bullshit. Like, yeah, this is our time distortion pattern, right? So here we're saying, yeah, it's just when these get layered on top of each other that it gets funky, you know? But if we, like, added this to that, or we could do cascading noise, you know? Where we use noise to then influence the noise to then influence the noise. And then we don't get as much interference because they're stacking at that point. I mean, I could use a texture-based, and it can tile at level 1. No, but this isn't computable on the dude. Like, yeah, we could distort the sign into the sign, you know, do like a cross sign wibbly wobbly. Where, like, you know, now this distortion pattern is distorted. And do that in both axes so that this one here, again, some big distortion pattern into there, multiplied by some amount added to the world position, then get the sign from that, then add them together. But I don't know, I mean, the waves look fine to me. So yeah, we could get like a more fucked up distortion pattern. The only problem is the more we use this time distortion, the waves actually start moving faster or slower at random points, you know? And you get these kind of weird, funky things going on. So, like, if we compare this here and how it looks to just the regular one, it's not really any different to me. So I guess just doing a really shitty, you know, sine wave thingo is fine for now. And that's just going to change the tiling in one of the directions, yeah. Prior to when they tipped over the Black Pearl runs a video game like it could go down. Yeah, yeah, with the physical character movement and stuff. You could definitely do that. Which would be funny as hell. Alright, so we'll just go with 2 noises and amplitude, and then I don't know, we don't even need an offset. Ocean, time distortion, 1. Blah, 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 blah. Amplitude. And then what's alpha? I don't know. It's just a dead value. Fuck it. Why not? Or do I just do the distortion based on the wavelength or something? Like, you know, we have the wavelength here. Can I not just do it based on some multiple of that? Because the aim is to just break up the Gerstner waves without needing to add more waves and increase the complexity. The heater's not on. I don't know why you're sitting there. Yeah, something I was thinking was, technically we could fade out the... I don't know. No, it doesn't matter. Alright, hurry up. Yeah, autosave these nuts. So, we've got world position GR. Why is it G and R? Why not R and G? That makes way more sense.